Alright, time for the last questions. And these are the ones that are most often missed on the test, this sort of question. So pay close attention to how this works. We're looking at a couple of graphs. This graph is a position versus time graph. First thing to do, anytime you see that, position versus time, remember for that your slope is your velocity. Okay? That's not even one of the questions, I'm just writing it down because I remember position versus time, slope is velocity. So it says to use the following graph and describe points A, that's this part, B, and C by their position, velocity, and time. So looking at point A, it looks like during this time we go from 0 to 30 meters. So that's the position part, 0 to 30 meters. The time it takes for that to happen is from 0 to 3 seconds. 0 to 3 seconds. And then to find velocity, I find the slope, which is my rise of 30 over my run of 3. So velocity, the entire time, is 30 meters per 3 seconds, or 10 meters per second. Distance changes and time changes, but because my line never changes slope during part A, I never change my velocity there. Do the same things for part B. My change in height, I'll look at it during B, I don't change any. I go from 0 meters to 0 meters, and no change of position. Time, however, still moves forward from 3 to 6 seconds. So this happens from 3 seconds to 6 seconds for a time lapse of 3 seconds. And my velocity, that's my slope, 0 meters divided by 3 seconds gives me 0 meters per second. It's time where the poor fool being forced to run stops and eats a cookie. And then we're on to part C. In part C, you'll notice this is downward. Remember, velocity. A negative velocity doesn't mean slowing down. Negative velocity means we're losing meters. We're going backwards. We go in this one from 30 meters. We go actually backwards past our starting point into the negative position range. We get down to negative 20. So I go from 30 meters to negative 20 meters. My time lapse is from 6 to 9 seconds. So from 6 seconds to 9 seconds. The velocity for this part, if I've gone from 30 meters to negative 20, that means I've lost a total of negative 50 meters during the seconds from 6 to 9 for a total of 3 seconds there. So I've lost 50 meters in 3 seconds. And according to my handy-dandy calculator, that equals 16.7 meters per second in the negative, meaning I have traveled negative 16.7 meters per second. I have a negative velocity, meaning I'm going backwards. All right. This next question has the same sort of thing. We're interpreting these questions. This one is also a position versus time graph, where I've got A, B, C, and D. On this one, we only have to do the speed, so we only need the slope. This graph, for some reason, photocopied really poorly, and if you've had a tough time reading this, now is your chance to get it clarified here. 0, 10, 20, 30, and 40 meters per second in there. So on the odd chance you didn't read that well before because it was poorly done, don't panic. I blame the government. So for part A, my slope is 20 meters. My over 4 seconds, my rise over my run, 20 meters over 4 seconds. 20 meters for 4 seconds gives me 5 meters per second. For part B, if you want, we can just glance at it and see, hey, it's a flat line, slope of 0, so my speed is 0 meters per second. We could also calculate it, showing we've changed 0 meters during the, let's see, it's from 4 to 6 seconds, so 2 seconds of that time, if that makes you happy. And then here during part C, it looks like I'm going from the 20 meter mark to the 40 meter mark. That's an increase of 20 meters, and that happens between 6 and 10 seconds. So I've increased 20 meters between 6 and 10 seconds. That's 4 seconds. So again, I'm back at 5 meters per second. We can also eyeball this. A here and C here, they look pretty parallel. They should have the same slope if they're parallel with the same speed. Our calculation seems to make sense. And then for this last part, I'm going from the 40 meter position down to the 20 meter position. I'm losing 20 meters. The time period during which that happens is from 10 to 12 seconds. So for 2 seconds. So I have negative 10 meters per second. Now, I know that that means technically what I have found there is velocity, because there's a direction. And the question asks me to find speed. Remember, if you found velocity, you have found speed. You've just also found direction. So there you have it. That is the majority of the test review. The vocabulary for your packet is definitely worth paying attention to. There's one other thing we've done that I really think is worth reviewing this evening. This page of notes we did the other day. I'll leave a few of these blank on our desktop in case you need them. We used a master page to kind of fill them in. I'll leave this here, and if you guys need this to review, please let the substitute know, and this can be paused so that you can review. Remember that this page is all about taking a position versus time graph and making it into a velocity versus time graph so you can see where they relate to each other. An object not moving can be expressed like this or like this, depending on the type of graph you want. Same thing's true for the rest. Whatever my slope is for my position time graph, that tells me my height, either vertical or my depth down here in the vertical as well, if I happen to have a negative velocity here. So this page is definitely worth reviewing. It's not the numbers so much as the pattern that we're really watching for. What's the shape of the graph? Remember, the whole value of a graph is to not have to do some math, but still get a ton of information. Your mission now is to finish this packet so that you're ready to hand it in tomorrow. If you need to work on it still, work on it carefully. If you are finished, follow the substitute's instructions. Don't drive anybody insane. You know who you are. I'm talking to you. You know it.